One, two, three,
Let's
go!
Good day, I'm Natrevor Movera, and I'm here to answer and discuss the questions assigned to me in our DC Motor quiz. So the first question is question number 16 from the EE board exam, April of 1990. The armature of a DC motor has 648 conductors, 65% of which are directly under the pole shoes, where the flux density is 48,000 lines per square inch. If the core diameter is 7 inches and its length 4 inches and the current in each conductor is 20 amperes, calculate the torque exerted by the armature. So the choices are A. 41.7 pound-feet, B. 34.7 pound-feet, C. 78.2 pound-feet, and D. 56.1 pound-feet. So let's solve for the torque to get the answer. So the given are the number of conductors, which is 648, and 65%, which is under the pole shoes. The flux density 48,000 lines per square inch, the diameter of the core 7 inches, the length 4 inches, and the current of the conductors 20 amperes. So first, we will solve for the force. Force is equals to flux density times current times length over 11,300,000. We put 11,300,000 so that our unit will be in pound-feet and not in dynes. So let's substitute the values, and since only 65% of the 648 conductors have 48,000 flux density, so we will multiply 648 to 0.65 and multiply it to 48,000. So 0.65 times 648 times 48,000 times 20, which is the current, and 4, which is the inches, over 11,300,000. So the answer is 143.133 pounds. So we have our force. Now we will solve for the torque. Torque is equals to force times the radius. So since we don't have the radius but we have the diameter, so we will divide the diameter over 2. So torque is equals to force 143.133 times 7 over 2, which is the radius, and since it is in inches, we will convert it to feet, and in 1 feet there are 12 inches, so 7 over 2 times 1 over 12. So the answer is 41.75 pound-feet. So that is now our torque. So the answer to this question is letter A, 41.7 pound-feet. So now we'll proceed to the next question, which is question number 37. In a DC motor, a unidirectional torque is produced with the help of A. Brushes, B. Commutator, C. End plates, and D. Both A and B. So the answer to this question is D, both A and B. So this is the commutator and this is the brushes. These are the brushes, these two. So what is unidirectional torque? Unidirectional torque is produced due to the action of commutator as As soon as the armature coil crosses the magnetic neutral axis, commutator reverses the connection and current in armature coil gets reversed. So, mana siya ang pag-produce sa unidirectional torque. So now let's proceed to the next question. Question number 58. So, a DC shunt motor is found suitable to drive fans because they require A. Small torque startup, B. Large torque at high speeds, C. Practically constant voltage, and D. Both A and B. So, the answer to this question is letter D, both A and B. So, these are DC shunt motors. As we start up a fan, the fan spins at a low speed, so the required torque is small. But as the fan continues to spin, the speed of the fan increases, thus the torque required for it to spin at that speed. That is why our answer is both A and B. Small torque the fan requires small torque at start up and large torque at high speeds. So that is our answer. So now let's proceed to the next question. Question number 79. Statement 1. A direct online DOL starter is used to start a small DC motor because statement 2, it limits initial current drawn by the armature circuit. So choices are A. Both statements 1 and 2 are incorrect, B. Both statements 1 and 2 are correct, C. Statement 1 is correct but 2 is wrong, and D. Statement 2 is correct but 1 is wrong. So the answer to this question is C. Statement 1 is correct but 2 is wrong. So statement 1 is correct. The statement 1 is a direct online starter is used to start a small DC motor because it limits initial current drawn by the armature. So statement 1 is correct. It is used to start a small motor. So what is a direct online starter? A direct online starter are primarily motors where high inrush current does not cause excessive voltage drop in the supply circuit from where this high voltage drop is acceptable. So dili niya i-kwan, so mo-kwan siya o current mo, it receives high inrush current. Unlike sa gisulti sa statement 2 that it limits initial current drawn by the armature circuit. So the answer is C. So now let's proceed to our last question, which is question 100. In figure 1 shows the DC shunt motor on no load. So this is the figure 1. Figure 1 shows the DC shunt motor on no load. So this is our figure 1. The quantity EBIA represents A. Input power to the armature, B. Copper losses in armature, C. Core losses, and D. Total friction and windage and core losses. So the answer to this question is letter D, total friction and windage and core losses. So what are these three losses? The friction and windage losses are caused by friction in the bearings of the motor and aerodynamic losses associated with the ventilation fan and the other rotating parts. So, mana friction and windage losses. So, ang core losses is the loss that occurs in in a magnetic core due to alternating magnetization, which is the sum of the hysteresis loss and the eddy current loss. So, mana siya ang core losses. So, these losses occur in the process inside the motor, in the process of converting energy in the motor. So,